This is Nitya, Assistant Professor, Department of Mathematics from St. Anne's Arts and Science College. In the last class, we had seen the definitions of non-increasing and non-decreasing sequence as well as the monotonic sequence. Today, we are going to see some important theorems based on the definitions. See the first theorem, it's very important. A non-decreasing sequence which is non-bounded above diverges to infinity. So we are taking the non-decreasing sequence that also a not bounded above. So that should be diverges to the infinity minus diverges to infinity. So we should know the definition of the non-decreasing sequence. We should know the definition of the bounded above as well as we should know the definition of the diverges to infinity. So we got seen all those things in the previous classes. So let us see the proof now. Suppose that the sequence Sn is a non-decreasing sequence. We are taking the sequence Sn is a non-decreasing and also it is not bounded above. So we are going to it to be a divergent to infinity. So we know that by the definition m greater than 0 we have to find n belongs to I such that Sn is greater than m. Sn is greater than m. Non-decreasing in the sense increasing sequence. So Sn is greater than m. And where n is greater than or equal to capital N. Since m is not upper bound, so it is not upper bound, it's not a bounded above, so it can be written as S1, S2, S3 and so on. The sequence can be written in the set format. There must be exits, so therefore there must be exist. Capital N belongs to I, belongs to the positive integers I in the real numbers. So Sn is greater than m. So from this equation it follows n is greater than or equal to n. Now from the hypothesis that the given condition non-decreasing sequence, we know that the theorem a non-decreasing sequence which is bounded above is convergent. This we know in the previous theorem. Last class one theorem we had seen. In that we had seen a non-decreasing sequence which is bounded above is convergent. Therefore from that theorem a non-decreasing sequence which is not bounded above is diverges to infinity. Okay, suppose if they are asking that question, if this if they are asking this theorem in 10 marks, you have to write this sub-theorem also. Otherwise, no need. Next theorem we can see, a non-decreasing sequence which is bounded below is convergent. So, if you are taking a non-increasing sequence and it is a bounded below, we have to prove that it has a limit. That is a convergent. We have to prove that it has a limit. That is a convergency. So, suppose we are taking the sequence as a non-increasing sequence and it is a bounded below non-increasing and it is a bounded below. In the questions they have given that non-increasing and bounded below, so we are taking that and we are going to prove it's a convergence. So let us take that a set is S1, S2, S3 is a non-empty set of R which is bounded below, So by the greatest lower bound axiom of R we must have the GLB. So m equal to capital M can be written as the greatest lower bound of that set sequence. So from that we are taking the maximum. So we shall prove that Sn tends to m as n tends to infinity. We know that given epsilon greater than 0 as m plus epsilon is not a lower bound for a, for n belongs to I such that Sn is less than m plus epsilon. But we know that the sequence is a non-increasing sequence. So Sn is less than m plus epsilon where n is greater than or equal to n. They take this as a first equation. But we know that since m is a lower bound, Sn can be greater than m minus epsilon. Therefore, Sn should be lies between m minus epsilon and m plus epsilon by the two equations. Now, Sn minus m should be lies between minus epsilon and epsilon. Therefore, by the limit of the sequence, modulus of Sn minus m is less than epsilon. So, as limit n tends to infinity, Sn equal to m. So it has a limit, the sequence has a limit as m, so it is convergent as n tends to infinity. So hence proved. Okay girls, so that is also an important theorem. So please practice well the theorem. Okay, next theorem, one more theorem we are having. A non-increasing sequence which is not bounded below is diverges to minus infinity. A non-increasing sequence means it's a decreasing sequence which is not bounded below, it's diverges to minus infinity. So let us take the sequence of real numbers which is non-increasing but not bounded below. But that the range a equal to S1, S2 is not bounded below. Given that m is greater than 0 and we must find such that Sn is less than m. As per the definition. So m is not a lower bound for a. There must be exist the real number n that belongs to the positive integers such that Sn is less than m, and as per the definition n is greater than or equal to n from this equation 1. Now from the hypothesis that the sequence is a non-increasing sequence. So as per the non-increasing sequence, and also we know one theorem, we got seen that a non-increasing sequence which is bounded below is convergent. Therefore, a non-increasing sequence which is not bounded below is diverges to minus infinity by the sub-theorem, this one. So if they are asking, you can write this also in the 10 marks. Okay girls, start learning. So now the unit 2 fully covered. So unit 2 ends now. So start learning. Thank you guys.